Hey everybody, Mr. Piercy here for the second part of the points, lines, and planes video, or lesson I should say. So what we're going to be looking here for the second part is now that we've identified what points, lines, and planes are, how we name lines, how we name planes, and what the difference between collinear, coplanar, non-collinear, non-coplanar, what those things are. Now we're going to be taking a look at some defined terms. The first defined term that we're going to be taking a look at is a segment. A segment is only going to be a portion of a line. Considering a line theoretically extends in opposite directions infinitely, well, it's not really practical for us to work with an infinite line. I couldn't draw an infinite line. We have to give ourselves some kind of a finite thing to work with. Even here, the arrows, that's what really tells us that something is continuous. Well, with a segment, we're only going to be looking at a portion of a line. And the way that we determine a segment is we're looking at 2 points on it, which we refer to as endpoints. So here we have a line that has 3 points on it, and I'm asking, can you identify them? Well, the segment, the symbol that we have for a segment is just a vertical or a horizontal bar where we just pick our points, A, B, in the example that we see in our terms. So looking at what we have here, I'm going to just start with point D. So if I start at point D, I can go to point E and create one segment. And the easiest thing to do to name another segment, or to name that segment a different way, would be to just simply turn the endpoints around. Because just like a line, the order of the points really doesn't matter for a line segment. I can call it DE or ED and refer to it as the same thing. Now moving on, I could say from point E to point F, that is another segment, and the simplest way of renaming it would be to just turn it around. And so we can have another set of segments. I can go from point D to point F, and again I can turn those around and say from F to D. So there's 3 particular segments that we could be looking at, but there's 6 different ways that we could name them. So that's what we're going to be looking at for segments right now as far as identifying them. Now moving on with our next type of defined terms, we're going to be looking at array. Now this is where things can start to get a little confusing for some students. When we're looking at array, we're only looking at part of a line. And even though a line is one-dimensional, we say it can travel in opposite directions, meaning I can either go front and back or side to side. But array really is only going to be going in one direction legitimately. And the way that we name it is a little bit different. In lines and in line segments, the order in which we use the points really didn't matter. Well, for array, we're still going to be looking at 2 points in order to be able to name it, but now the order in which we name it really does have some significance. And there's a little bit of confusion on some parts, because if you look at the definition of what array is, it tells you that it's all the points on one side of an endpoint. Now, to me, the way that I look at an array is I take the endpoint and I say that's actually where I start. And the second point that we look at on the array tells me where the array actually goes. So in this case, the diagram that we're seeing here, we're naming it ray AB. So point A is an endpoint. That actually tells me where I'm starting. And point B tells me where I'm going. Now, I mentioned a second ago that the order in which we name our points really matters. Now, when we're naming an array, the endpoint must be the first thing that we name. or the first point that we use, which again kind of seems a little backwards to me when I say, well, we have to, the first of something has to be the end point. The first letter has to be the end point. So it can be a little confusing, I grant you that, but keep in mind what we're doing. Now, let's say, for instance, let's take a look at this symbol. The symbol that we use for array, the symbol does not indicate a direction. And it can be a little confusing because looking at the array, the example that's provided for us by our textbook, we start at point A on the left and we go to point B on the right. So some students are thinking, well, because that's the direction that the array went from left to right, that's the way the symbol should look. And it really makes no difference. The symbol doesn't indicate a direction. It just says that we're talking about array. So here let's name all the arrays in the figure. So let's start at point D again. So here I'm going to look at D and I'm going to kind of go to the right because that's where my points are. So to name that, I can say array DE. And I didn't make that E look very nice, so let me clean it up a little bit. So array DE. Now, is array DF? Let's look at that. Is array DF the same as array DE? Okay, so maybe if you're sitting in a classroom with somebody and you're getting to this point at the same point in time, maybe you want to talk to each other, pause the video, and do that. But when you're ready, start it over and we'll see. So DE and DF, because they have the same endpoint and they travel in the same direction containing points D or F, these are actually identifying the same array. They are not different. All right, well, let's try this another way. Let's say DE. Let's take that same array again. And now let's say array EF. Are those the same array? Well, DE starts at point D and then goes through point E. Whereas array EF starts at a different place. So because they have different starting points, and let me clean that up a little bit. Instead of saying DE, let's say DF again. Is DF the same thing as EF? Because there's, have that common point F there. Are they the same? And the answer here, again, is in this case, no, these are not the same. These are different. And even though they start, or even though they head towards the same point, F, because they have different endpoints, or rather different starting points, they're different. So we have DE, DF, and EF. So we have some arrays going that way. And we could also name them going in the other direction. So for instance, let's pick a color here that's different than blue. Now let's start at F and head the other direction. So again, if I say array FE, or if I say array FD, again, these are the same. So there's one array, but now I could also pick a different endpoint with which to work. I could say array ED, and I could say array, where am I at? I'm losing my track here. So FE and EFD are the same. ED is one, and ED and FD are going to be different. So I think that's pretty much it as far as arrays here. So FD, that's different than ED. So, but I have it twice here. But there we go. Those are pretty much how we're going to be identifying the arrays here. Now, keep in mind, the order matters when we start to name arrays, And the first letter in the name has to be the end point of the ray. The second point simply tells you what direction that you're going. And speaking of rays, let's take a look at what opposite rays are. So what I want you to do is I'm going to ask you a question, and I want you to answer this question yourself. And when you're done, come back and see whether I agreed with you or not. So let's take a look at these rays. We're going to take a look at ray DF, which is here going that way, and pick another color here. And let's say ray FD. Are these rays opposite rays? Are these opposites? I want you to pause the video and think about it for a second, and if you have a partner available with you in the same classroom, maybe talk it over. And when you're ready, when you've made your decision, come back and watch the rest of the, pick up the video where you left off. So pause it now, figure out yes or no, come back. All right, so now that we've had an opportunity to look at it, so here's FD, we're going that way. I know that should have been blue. Are they opposite rays? And the answer is, without a doubt, no, they are not opposite rays. And I'm going to the question first. I'm asking you this question first before discussing anything in the text box to see, are you really paying attention to it? And the thing that really tells me what opposite rays are is that they have to share the same endpoint and form a line. If they're not sharing the same endpoint, they cannot be opposite rays. So the only real opposite rays that we are going to see here would be ray ED and ray EF. Those are the only opposite rays that we see in this diagram. So the last thing that we're going to look at here is just kind of some basic stuff. This is some very fundamental type of questions that geometry curriculums like to ask. How do these things interact with each other? So take a moment. I want you to pause the video now and try to answer the 4 questions that you see in your notes. And when you have answered, then come back and see what we have. Okay. So now I'm assuming you paused the video and you're coming back to it now. So AB and BC, where do they intersect each other at? Well, AB and BC on the diagram, they both touch each other at point B. So here I would say they intersect at point B. So let's say point. And EG and GF. Well, EG is not a line that's specified by the prism, but that's okay. Any 2 points automatically contain a line, whether it's drawn first or not. And GF is right here. So again, those two connect at point G. Now, if you are looking at the diagram itself, that's perfectly fine. It's very natural for us to want to do it. But I do want to point out that here I'm saying AB, here I'm saying BC, and they intersected at point B. Here I'm saying EG, here I'm saying GF, and they intersected at point G. So sometimes simply the name of the segments that we're looking at will tell us where they intersect. All right, so let's look at our segments. Let me clean this up here, and let me maybe even pick another color. Let's go blue again, I guess. What is the intersection of these planes? Well, ABC is the face that would be at the top of the prism, or the cube, whatever this might happen to be. And BCG would be this one right here. And where they meet each other at happens to be right there. They don't intersect at a point. These are going to actually intersect at a line or a line segment. So here I might say segment BC or segment CB, however you want to write it. And my pen got wider doing that. There you go. And so the next one, well, let's look at the, let's clean that up. So let me try getting a clean slate here. All right. and we'll do red this time. So now we're looking at what is the intersection of EFG. Well, EFG is this face. That would be the plane that creates that face at the bottom. And GCB would be this right here. So again, you can kind of see that the planes don't intersect at a point the way the line segments did. These are intersecting at a line. So in this case, we could say line segment FG or GF, whichever one you wanted to say. So the blanks at the bottom are really kind of, we really needed to answer these 4 questions first to really kind of see, well, what do we put in here? So 2 lines, what we see for the first 2 questions, they are going to intersect at a point, whereas planes will intersect at a line of some kind, a line or a line segment. So that is going to kind of conclude some of the basics that we talk about in geometry for the first time. And from here, we're going to be getting into a little bit more detail, but we're going to be looking at little things here and there. We're not going to just throw it all at one time. So try not to worry too much about how much we're going to give you. But again, any questions that you have as you're going through these, because when we went through this stuff in the classrooms, kids were asking a lot of really good questions just to clarify their own understanding. As you're going through these lessons, what I want you to do, anytime you have a question that you're not sure about, write it down and make sure you either leave it for me in a comment in the Google Classroom or send it to me in an email, and I'll get back to you as soon as I can. But anyway, thanks again for watching, guys. I look forward to hearing your comments, answering your questions, and seeing how things go from here. And until the next video, take care of each other, all right? See you later.